Students, we will discuss about functional gauge in this session. There is a component which is shown in this figure. This component is having 4 holes whose size is 12H8. These 4 holes are to be located within a position tolerance of 0.5 mm applicable at MMC. When you manufacture this component as mass quantities, say 1000 numbers or 5000 numbers, after manufacturing all the required number of quantities, we have to check for its size. For this, we have to check for the size of the hole. The hole are to be drilled within a tolerance of 12H8. So the 12H8 tolerance is plus 00 plus 0.27. So the lower limit of the hole is 12 mm, upper limit of the hole is 12.027 mm. All the hole are to be drilled within these two limits. When the hole is at its lowest size, the component will have maximum material. So in that case, the MMC size of the hole is 12 mm. When the hole is drilled to its lowest size, the component will have maximum material. So 12 mm is the MMC size of the hole. So this 0.5 true position tolerance is applicable when the hole is drilled to a size of 12 mm, which is the MMC size. When the hole is drilled using a drilling machine, the size of the hole can vary depending upon the pressure applied on the tool. So the hole size may vary 12.01, 12.02, but all the samples should have a holes size between 12 mm and 12.027. So when the hole is measuring 12.01, the applicable value of tolerance is 0.6. When the hole is measuring 12 mm, the applicable value of tolerance, position tolerance is 0.5 mm. So for each and every sample, for each and every hole, the size of the hole may vary depending upon the process parameters. We have to check for the correctness of the drilled hole for its size as well as for its location. When you manufacture this component in mass quantities, we have to devise an efficient and time-saving method for checking its dimensional correctness. So there are two things to be checked. One is size of the hole, other is location of the hole. For checking the size of the hole, we can make use of a plug gauge. So a plug gauge can be used to measure or to check the size of the hole. So one side is go, other side is not go. So the hole should be within 12 mm and 12.027 mm. So the size of the hole on all the samples can be checked using plug gauge. For checking the location of the hole, we have to use a functional gauge. So the hole ought to be located within a position tolerance of 0.5 mm applicable at MMC. To check whether the hole have been located within the applicable value of 0.5 mm, we are using a functional gauge which is shown in this figure. So this is the functional gauge that we have to use for checking the location of the hole on all the samples. After manufacturing this functional gauge, then all the samples can be checked for its location. So the sample 1 is put inside the functional gauge. If it is going inside the functional gauge like this, the sample 1 is okay with respect to location. So before using this functional gauge, we have to use the plug gauge for checking the size of the hole. Second sample, you are making the second sample, then you are putting on the functional gauge. If it's not going inside, means you can try to move the component either in the x direction or y direction, or can rotate. By making this kind of manipulation, you can try to make this component go inside the functional gauge. even after doing these manipulations, if you are not able to make the component to go inside, that component is rejected because the holes are not located properly. So this functional gauge is used to check for the location of the hole. The plug gauge is used to check for size of the hole. What should be the size of the pin on this functional gauge? For inspecting this component, which is having a hole drilled with a location tolerance, position tolerance of 0.5 mm, what should be the size of the functional gauge pin? So this formula is applicable. The size of the functional gauge pin is MMC size of the hole minus position tolerance of the hole at MMC. For the sample drawing, what is shown, the MMC size of the hole is 12 mm and the applicable value of position tolerance at MMC is 0.5 mm. So 12 minus 0.5, 11.95. See, so now this hole is having a size tolerance of 12H8. The MMC size of the hole is 12 mm. The applicable value of position tolerance is 0.5 mm at MMC. So substituting those values, we are getting the functional gauge pin size as 11.95. So the spin, all the 4 pin has to be sized to a size of 11.95. Now this is the final drawing of the functional gauge. Now this is the isometric view and this is the orthographic view of the functional gauge. The pin diameter is found out as 11.95 using the formula we have discussed earlier. Now there are two projections to control the location of the hole with respect to the datum surfaces. See, these 4 holes are to be located with the datum B and datum C. So from datum C, the first hole is 30 mm in y direction. Similarly, from datum B, the first hole is 35 mm. So to control the location of the hole with respect to the 2 datum faces, we have on the functional gauge this side projection. So this is how we have to calculate the size of the functional gauge pin for checking the hole on a plate. Now, as a second case, the component is having 4 pin projected on it. So this is a different component we are discussing. This component has to be inspected for its size and for its location. The pin size can be checked with the help of a ring gauge or snap gauge. The diameter of the pin can be inspected with the help of a snap gauge or ring gauge. The location of the pin should be inspected with the help of a functional gauge. Now this is the functional gauge that is used for inspecting this component which is having 4 pins projected from the base. So this functional gauge we have to design for inspecting this component. How to arrive at the functional gauge hole size? This size of the hole or the functional gauge we have to decide using this formula. So size of the functional gauge hole is given by MMC size of the pin on the component plus position tolerance of the pin at MMC. So what is the MMC size of this pin on the component and what is the position tolerance at MMC? So now this is the component diagram. The pin is having a size of 10H6. If you look at the tolerance for 10H6, minus 00 minus 0.09. So all the pin has to be within the upper limit of 10 and the lower limit of 9.991. So what is the MMC size of this pin? When the pin is having a maximum size, the component will have maximum material. So when the pin is produced to its maximum size, the entire component will have maximum material. So 10 mm is the MMC size of the pin. So the tolerance applicable at MMC is 0.8 mm. Okay, as per the drawing, the location tolerance, position tolerance is 0.08 applicable at MMC. So when the pin is produced at a size of 10 mm, the applicable value of position tolerance is 0.8 as per this drawing. So now using this formula, using the formula we have discussed, we are going to find the gauge hole size. So the gauge hole size, yes, now the gauge hole size is to be found out using this formula. Size of the functional gauge hole is equal to MMC size of the pin plus position tolerance of the pin at MMC. So looking at the diagram of the component, the MMC size of the pin is 10 mm. The position tolerance applicable at MMC is 0.08. Adding together, you are getting the size of the functional gauge hole as 10.08. So 10 plus 0.8 is equal to 10.08. So this is how we have to arrive at the size of the functional gauge hole for inspecting this component, which is having 4 cylindrical projection from the base. After manufacturing the functional gauge, for checking the position of the 4 pin on this component, we can make the functional gauge, we can place the functional gauge over the component first sample. If the functional gauge is able to be inserted well into the component as shown in this figure, that component is okay with respect to its location. If the functional gauge is not able to be inserted over the component, then the component is to be rejected because the 4 pin are not located as per the given drawing.